What's up, guys? Back again, and we're talking about the mechanism for halogenation of alkanes. Basically, this mechanism is going to take place in three types of steps. The first is what we call initiation steps. The type of mechanism is called free radical chain reaction. A free radical is a molecule or an atom with a single unpaired electron. That unpaired electron is very unstable. And so that atom or molecule will do whatever it can to pair that electron up. That makes them very reactive. Free radicals are responsible for a lot of different types of reactions in organic chemistry. This is probably the most common and certainly the most famous, if you want to give it that. Here's basically how it works. Remember that we said light or heat is a catalyst. I'm just going to go with light because that's the most common one that's used. We're going to start with our halogen. Now remember that halogens are diatomic molecules. So here's a Cl2 molecule with its valence electrons. In the presence of light, what happens is this bond in the middle of the two chlorines, this single covalent bond, is broken. But it's broken, what we say, it's broken in a homolytic fashion. Homolytic means that the bond is broken evenly and one electron from each goes to each chlorine. So I indicate that with a curved arrow and a half arrowhead. Okay, that's how I show one electron moving this way, one electron moving this way. Okay, what that gives us then is two chlorine atoms with one unpaired electron. This is a free radical, two of them actually. Okay, that's the initiation step. The reaction can't proceed unless this happens. Okay, so the next step then, and some steps subsequent to it, are called propagation steps. Okay, every time a free radical encounters another molecule, a reaction is going to happen. So for example, if I use methane as my molecule, my alkane that's going to be reacting here, and I bring in and react it with a chlorine free radical, the chlorine free radical is looking for electrons. Okay, and so what happens is it will grab an electron from this bond between the hydrogen and the carbon. It'll actually take the hydrogen with it. Okay, and this doesn't require any kind of catalyst at all. The catalyst is the chlorine free radical. So we end up with then a methyl free radical. So this methane, this bond between the hydrogen and the carbon was broken homolytically. One of the electrons stays, one goes with the hydrogen, and the hydrogen goes over here to give us HCl. This is now another free radical, which if it encounters, for example, a chlorine, so here's my methyl free radical, okay, and if we encounter then a Cl2 molecule like this, that unpaired electron on the methyl free radical is going to cause another split. It's going to then join to the chlorine, and we're going to get the chlorinated alkane, in this case chloromethane, and we're going to be left over we're going to have left over a free radical chlorine. This free radical chlorine can come back over here, find another methane molecule, continue to make these methyl radicals. Methyl radicals can continue to make chlorine radicals and chloromethane, and so on and so forth. So these steps together are called my propagation steps. Okay, we continue to make the methyl chloride. Now, you may have noticed, though, that what would happen if, say, a chlorine radical, or a free radical chlorine, or a free radical methyl encountered another one of the same type? Well, if that's the case, then we are going to see what are called termination steps. So I'll show you what that looks like. If, for example, a chlorine radical, instead of encountering a methyl radical, encounters another chlorine radical. If that's the case, then these two are going to share a pair of electrons to form Cl2. Well, Cl2 is non-reactive anymore, it's going to be stable. Similarly, if a methyl radical encounters another methyl radical, these two are going to pair up their electrons, and they're going to make ethane. which is also stable, no longer reactive. Okay, so these two steps here these are called termination steps. If they happen, then those molecules are taken out of the game. Okay, and we just keep going until we just reach, all molecules have reached a terminal point. So you are going to get a little bit of ethane in this reaction, not very many, because these molecules are pretty big and they have to encounter each other, and generally they're going to meet up with the chlorines, especially if you use a little bit excess, and they're going to form the chloromethane rather than the ethane. But you will get a little bit of ethane, and a little bit is detected there. Okay, so that's essentially how the mechanism for this reaction works. It's free radical chain reaction. The propagation steps continue and continue and continue until you run out of molecules or start running out of molecules, and then these termination steps happen, and eventually the reaction is done.